Okay, here is the last video clip for the gas unit. It is dealing with the ideal gas law. And so up to this point, we have been using the combined gas law. So the combined gas law, P1, V1, N1, T1 is equal to P2, V2, N2, and T. So we've always had changing conditions, starting at one pressure, going to a different pressure, starting at one volume, going to a different volume. What if you're faced with a situation where you're not changing conditions, but you actually don't even know what all the starting conditions are? So for example, this question. I've got a 20-liter container at 5 atms and 25 degrees Celsius. How many moles are in my container? So I have a volume, 20 liters. I have a pressure, 5 atms. I have a temperature, 25 degrees Celsius or 298 K. I don't have moles. And I don't have any changing conditions. So I technically, if you go back and think about the combined gas law, I'm missing 5 variables. How do I deal with that? Any suggestions? Can you think of anything? Well, if you remember from the last video clip, we learned a set of standard conditions that are always true. So if I take that combined gas law and set one side equal to standard conditions, now I'm back to just having one unknown variable. So that's what we're going to do. We're going to fill in. Now I'm going to do things a little backwards because we're not going to isolate the variable first. I don't want to do that because since my standard conditions are always the same, I'm going to solve this side of the equation. So 1 atm and 22.4 liters and 1 mole of gas and 273 Kelvin are my 4 standard conditions. So if I figure that number out mathematically, I get a value that's 0.082. I'm just going to round off to that. 0.082 units. All of the units apply. ATM, liters, K, mole. This is what we call the ideal gas constant. It is the numerical value that you get when you solve PV over NT with the standard values. So my left side hasn't changed yet. I still have P1, V1, N1, T1, but now I can set that up to equal to standard conditions. They call this gas constant R. I don't know why. They're running out of letters, I guess. Anyway, so R is what we refer to as the ideal gas constant. So I can rewrite the equation like this, so that if thinking back up to the problem, if I have not changing conditions, but one set of conditions for which I don't know all of the values, I can use this ideal gas law. Although writing it this way isn't nearly as common as writing it this way. So, oops, I don't need the ones there. So this is what we refer to as the ideal gas law. So with that in mind, I can now go and solve my problem because my one unknown, my N1, is equal to PV over RT. I can put in all my values. Pressure is 5 atm. Volume is 20 liters. R, gas constant, 0.082. Yes, you need the units. And then my temperature is 298 Kelvin. If you look, all the units cancel except 4 moles. I've got Kelvin canceling, I've got liter canceling, I've got atmospheres canceling. I'm left with moles, and that's it. So if I solve this problem, again, give me a moment to pull out the calculator. It turns out that I have just slightly over 4 moles of gas in that container. So a little bit shorter than the combined gas law because you already know one side of the equation. You are most likely going to see the ideal gas law written as PV equals nRT. That's the more common way to see it written. Makes it easy to solve all the unknowns because you just isolate the variable by moving the variables that you do know to the other side. But instinctively, this is what you learned first, so that may be the way you want to remember it. But if I give you the equation, you find the equation anywhere else, it's going to be written as PV equals nRT. All right, so you got one last set of problem set to do, which asks you to use the ideal gas law and the ideal gas constant. So good luck with that.